What's up, everybody? It's your math teacher, Miss Sorensen. Make sure you hit subscribe on the bottom so I can get lots and lots of likes. All right, let's go ahead and start video 4, z-score. A z-score, which is also known as a standard score, however, we're only going to refer to it as a z-score for the rest of the day. A z-score tells you how many standard deviations away from the mean you are. Well, let's add some numbers to this example. Let's say the average test score on our first test is an 88, and the standard deviation is 2. Okay, so if we go ahead and mark this up, we've got 88, 90, 92, 94, 86, 84, 82, 80. Guess I can go one more here, 96. All right, now, if I told you that my z-score on this test was a 3, you would know that I'm significantly above average, and more specifically, you would actually know that my score was a 94. If I told you that my z-score was 0, you would know that I'm exactly average, meaning that my score was an 88. All right, what if my z-score was a -2? That's a bad thing. That means that I'm below average. How far below average am I? Well, I'm 2 standard deviations below average. So let's find that right here. Okay, 2 standard deviations below would be an 84%. Z-scores and location. By itself, a raw score of X value provides very little information about how that particular score compares with other values in the distribution. For example, a score of 53 may be a relatively low score, or an average score, or a really high score, depending on what the mean and the standard deviation for the distribution from which the score was obtained. So we really get no information from saying I scored a 53. We would get much more information if you gave a z-score, right? If I gave you a z-score of 2, you would say, oh, they scored way above average. Or maybe a z-score of 1, you'd say, oh, they scored a little bit above average. Or if I gave you a z-score of 0, you'd say, oh, they were average. Or a z-score of -3, you'd say, whoa, they blew it. All right, last point here. If the raw score is transformed into a z-score, the value of the z-score tells exactly where the score is located relative to all other scores in the distribution. So basically, how good are you compared to others? Or how bad are you? Or how average are you? It's much more useful information. Let's talk about beauty, standard deviation, and the z-score. Oh my. Let's calculate the z-scores for these celebrities. And let's say that our average attractiveness is a 5. So what does that mean? That means my X bar is 5. And the standard deviation, in this case, we'll call it SD, equals 1. Assume attractiveness is a normal distribution. Now, I have no idea who this guy is. I think he's like a Jonas brother or something. Anyway, let's go ahead and rank him for attractiveness. I hope he's above 18 or this is a little bit creepy. But yeah, he's a nice looking guy. I'm on a scale from 1 to 10. I'm going to give him a 7. You know, I don't know what his teeth look like. He's not really opening his mouth. All right, now this person in the middle, also no idea who she is. Maybe like Natalie Portman or something. She's good looking. I really like her. I think her hair's a little frizzy, you know. She's looking off to the side. I can't really see her eyes, so I can't rate her that highly. I'm just going to go with an 8. I think she looks nice. Now this guy here is a good musician. I think I know he like does Your Body is a Wonderland or something. Anyway, I'm going to give him a score of a 3. Don't tell him I said that. He's probably really rich and doesn't care, but I mean, he's nice looking, but like, is he that good looking? Not really. So let's go ahead and let's find their z-score. Right, because if I told you, hey, he's a 3, you don't even know if 3 is all that good or all that bad. We need to know relative to everything else. So let's call this guy Jonas, because I think he's a Jonas brother. And let's find Jonas's z-score. All right, we're going to take his value, right? X stands for his value, and that's going to be a 7, minus our X bar is our average. Okay, what's our average? Remember, it's right here. It's a 5. Divided by a standard deviation, here that is given to us as 1. So 7 minus 5 divided by 1 is 2. Okay, meaning that he has a z-score of 2. Well, he's above average. He's pretty darn above average. Again, hopefully he's over 18. All right, next one is a Natalie Portman. I think that's who this is. Let's go with Natalie. She's got a value, an X of 8. We're going to subtract the average, divide that by our standard deviation, and she gets a 3. Yeah, she's nice looking. So she's, significantly above average. If you give a z-score of 3, you're like, whoa, she's positive. She's got a positive 3. She's significantly above average. All right, let's go back to this guy, Ed Sheeran. Literally nailed that one. Ed Sheeran? Sheehan? I don't know. I'm just going to go with Ed S. Super safe, Ed S. Body is a wonderland. All right, his body's not really a wonderland, so we're going to calculate his z-score. He's going to be a 3 minus 5 divided by 1. And I'm just using this formula right here, plugging right into that. And that's going to give me a negative 2. So let's talk about what that means. He's got a z-score of negative 2. First of all, the fact that he's negative means he's below average. And even this 2 means he's significantly below average, but not as below average as someone with a z-score of negative 3. All right, let's move forward. Let's answer this question. If Judy got a z-score of 1.5 on an in-class exam, what can we say about her score relative to others who took the exam? Go ahead and pause this video and put a check mark next to the ones you think are true and X next to the ones you think are false. All right, is it true that Judy is above average? Well, yes, that is true because a 1.5 is greater than 0, meaning she is above average. Is it average? That's a no. What would you have to have as a z-score to be average? You would need a z-score of 0, so that's not the case. Is it below average? That's a no as well. What type of z-score would you need for being below average? Yeah, you'd need a negative. All right. And is it a B? We actually have no idea. I'm going to put a question mark, and I guess you could put an X as well. It could be, but we don't know because maybe the score was like your APTP test where it's out of 160 or something like that. So we don't really know that. We just know that Judy is above average. All right, let's talk about transforming back and forth between X and Z. So let's say Miss Sorensen had a z-score of a negative 0.8. How attractive is she on a scale from 1 to 10? And let's also remember that standard deviation in this particular example was 1 and the mean is 5. So what am I solving for here? How attractive is she? That would actually be X that we're solving for. What's her value? What's her attractiveness value? So we're going to say that this is our value. That's going to be our question mark. This is obviously our z-score. This is standard deviation, obviously. And this is our average. So let's plug in. So we've got X equals negative 0.8 times my standard deviation of 1 plus X bar. Well, X bar is our average. In this case, it is 5. We do that math out. We get a negative 0.8 plus 5. Miss Sorensen is at a 4.2. Now, you are absolutely welcome to memorize this formula. However, you don't actually need to memorize it because we can derive it from the equation that I just gave you. So let's go back to that equation, z equals x minus x bar over SD. I'm going to multiply by standard deviation on both sides. Okay, this is going to cancel, and I'm left with z times SD. I just rearranged that because I wanted to. And I'm left with x minus x bar. Now I'm just going to add x bar to both sides. Okay, and then I'm going to be left with z times standard deviation plus x bar is equal to my x. And you can notice that this is the same exact formula that I used right here. All right, thank you folks for listening. That was a whole lot of fun. I hope you know how good I am at celebrities and z-score now. All right, bye-bye.